Large quantities of water occur below the surface in the pores and cracks of soil, sediment, and rocks. Precipitation percolates downward to the water table. Below the water table, all pore spaces in the sediments and rocks are filled with water. This is called the zone of saturation, and the water here is called groundwater. The water table is rarely level. Instead, its shape is a subdued replica of the surface topography. That is, the water table is highest under hills and lowest in valleys. The height of the water table fluctuates. During droughts, it drops. And during wet periods, it rises. Above the water table, pore spaces are unsaturated and filled mainly with air. This is called the zone of aeration. The zone of aeration can be further divided into the zone of soil moisture, the intermediate belt, and the capillary fringe. Soil moisture extends downward to where plant roots end and is the zone that has the greatest variety and magnitude of biological activity. Some of the water in the capillary fringe moves upward in tiny thread-like passages between grains of soil or sediment. It is similar to what happens when a strip of paper towel is placed in water. Place each of the labels in the proper place on the diagram. Only about 0.6% of Earth's water is found underground. However, when the oceans are excluded and only sources of fresh water are considered, the importance of groundwater becomes more apparent. Obviously, the greatest volume of fresh water is locked up in glaciers. Since most glaciers are in remote places, they are not a major source of fresh water for people. After glaciers, the greatest volume of fresh water is found beneath the surface as groundwater. When ice is excluded and just liquid fresh water is considered, more than 94% is groundwater. Groundwater is a very important source of drinking water and water used for irrigation and industry. Groundwater has important geological roles as well. In humid regions, it contributes significantly to the flow of streams. In regions underlain by soluble rock, such as limestone, the dissolving action of groundwater creates sinkholes and caverns. The list above represents major sources of fresh water. Rank them from 1 to 5, with number 1 having the greatest amount and 5 having the smallest amount. The quantity of groundwater that can be stored depends on the porosity of the material. Porosity is the percentage of the total volume of rock or sediment that consists of pore spaces. Permeability is the ability of a material to transmit a fluid. If pore spaces are too small, surface tension keeps the water from moving. Larger pore spaces in well-sorted sandstone account for its high permeability. Rocks and sediments, such as shale and clay, have such tiny pore spaces that they are nearly impermeable. Such materials are called aquithards. Permeable rocks and sediments have larger interconnected pore spaces and transmit groundwater freely. Such materials are called aquifers. The presence of springs and the productivity of wells depends on the permeability and distribution of subsurface materials. Springs occur when the water table intersects Earth's surface and a natural flow of water occurs. Sometimes springs form when an aquitard is situated above the main water table so as to produce a perched water table. Wells, the most common method of obtaining groundwater, are holes that penetrate well below the water table into the zone of saturation. When water is withdrawn from a well, A depression in the water table may develop called a cone of depression. When pumping from a large well is great, the cone of depression can be large enough to influence neighboring wells. In some places, groundwater is being mined. That is, it is being withdrawn far more rapidly than it can be recharged. When the water table is lowered in areas underlain by unconsolidated sediments, significant ground subsidence may occur. Some places have artesian wells. Artesian applies to any situation in which groundwater under pressure rises on its own above the level of the aquifer. For an artesian system to exist, water must be confined to an aquifer that is inclined so that one end can receive water. And aquitards must be present above and below the aquifer. When an artesian aquifer is tapped, the pressure created by the weight of the water above will cause the water to rise. For each question, click on the correct well in the diagram.